In the previous video, we got to know how planetary nebula is formed, and today the show will continue. Let us explore the reasons behind the diverse colors of our beautiful nebula.
My spectra are dominated by discrete emission lines emitted by atoms and ions. My bright emission lines are powered by the central star. Ultraviolet light emitted is intercepted by atoms in me and converted into visible line radiation. First, the ultraviolet light removes electrons in the process called photoionization. The free electrons then either recombine with the ion and emit a recombination line, or collide with other atoms and ions to cause the emission of a collisionally excited line. These lines are very prominent. The exact color depends on the temperature of the hydrogen, which influences the relative intensities of the hydrogen emission lines. Increasing dust suppresses blue colors. If there were no dust, the hydrogen emission would produce shades of blue. Small amounts of dust produce pinkish colors and are commonly seen in my images made with color-accurate cameras. I appear red in regions of high dust. My relatively high oxygen emission makes me appear blue-green in natural color. My colors are very saturated because they are produced by narrow emission lines, which makes me very colorful.
You're a fake. You just look grey.
Pardon me, but you're just too pathetic to see my beauty. Your eyes are deceiving you. With a telescope, most of the perceived color seen by visual observers is relatively poor. The problem lies in the loss of color vision at night of human beings, whose apparent mechanism lies with the rods and cones of the human retina, which measure the intensity of light and color respectively. Since there is not much illumination, which is needed for the wavelengths coming into the eye to separate into their component color and be sent along the optic nerve of the brain to be interpreted as color, during the night, much of the color is lost to your eyes. As a consequence, you normally only see grayness.
That is indeed fascinating. Do tell us more.
When you look through any telescope, you are just exposed to the illumination of the stars and the astronomical object in question. Saturation is roughly 10%, and very few color hues are shown. Color saturation simply is described as the degree of whiteness in any perceived color. In astronomical objects, these produce fairly pale colors and never intense ones. That's why most images are false color images, so as to know more about what I'm made of.
So, what you're saying is that you are indeed colorful, but humans cannot fully see your colors, so they use false color images to help them with identifying your true colors and your components?
Yes, did that answer your accusation, human?
Yes, I'm sorry. I guess we humans are still trying to learn the secrets of this universe.
The tea has been spilled, folks. Well, that's all for today. If you want to learn more juicy information like we did today, join us next time to know more about the rest of the nebulae and pick your favorite stellar nebula. This is your host, Mr. Meteor, signing off. Till next time.
This should be everything that I want to share about the planetary nebula. If you like the video or the method of hand drawing, do hit the like button or leave a comment below. If you have any other interesting physics topics you want to learn about, you can also tell me in the comment section as well. See you in the next video.